Hello, this is Beth Dixon from Walter State Community College, and we are working through the review for Math 0030, and we are on problem number 9. So let's pick up and start it immediately so we don't waste any time. I'm going to reset my timer so I've got an idea about how long these videos are taking. Okay, let's start with number 9, and it says find the unknown length of the right triangle. The key word here is that these are right triangles, and we're going to round our answers to 2 decimal places. Always refer to your teacher or your directions to know how to round your answers. In doing the Pythagorean theorem, you want to remember that we're doing c squared equals a squared plus b squared, or a squared plus b squared equals c squared. And we want to make sure that we know and label our sides correctly. Then in the problems, we have 2 types of problems. We have problems where the side is, one of the legs are missing, and then we have ones where the hypotenuse is missing. So let's look at this first one here. As we look at this problem, there is the right angle, and so across from the right angle is the hypotenuse, so that makes that side the C, and then the other sides are my A and my B. So the first thing I'm going to do is label my sides of my triangle. Then I can fill in, and since it's c squared equals a squared plus b squared, I have 8 squared equals x squared plus 7 squared. My 2 legs then are the unknown side and the 7 squared, and the 8 goes by itself because it is the hypotenuse or the longest side. So it goes over here by itself. 8 squared then gives me 64, and you can't see that because it's at the bottom, so let me raise that up so you can see it. So that is 64 equals x squared, and 7 times 7 gives you 49. At that point, what do? That is not your answer. The next part is to subtract 64 minus 49. You will either add or subtract. If you're given a number on each side, if you're given a number on here and a number on here, on either side of the equal sign, you will always subtract. And so that gives me that x squared equals 15, or technically, I guess in this case, that's 15 equals x squared. I'm going to flip-flop that because I like my x on the left-hand side. Then you're still not done because the answer is not 15. The side squared gives me 15. So x equals the square root of 15, because if I take the square root of both sides, that gives me x by itself. And so on the calculator, I go second square root of 15, and that gives me approximately 3.8729. Now I wrote it out 4 decimal places so that you could see how to round this to 2 decimal places. That means I look at the third number, and it tells me that I do not change the 7 because that 2 is not 5 or more. So this is approximately 3.87. Because I do not have a lot of room to work these out, I'm going to switch over to a different color so you can tell one problem from the next. In this one, again, I'm going to come across and label the hypotenuse first. Across from the right angle is my C, and then my legs can be A and B. Again, we're dealing with c squared equals a squared plus b squared. My c is labeled as y, so that is the unknown. So that would be y squared equals 9 squared, which would be my a, plus b squared, which would be my 6. So that gives me y squared equals 9 squared plus 6 squared. So when I look at this, notice at this time, my unknown is my hypotenuse. Here, my unknown was my leg. So when my unknown was my leg, I ended up subtracting, it keeps falling down, I ended up subtracting my 64 and 49. Over here, my unknown is my y squared. So my numbers, 9 squared is 81, 6 squared is 36. So that gives me y squared equals 81 plus 36. These numbers are on the same side of the equation, the same side of the equals. So I will add those numbers. And again, I will take the square root, and that will give me the square root of 117. The second square root, I hit the second key, and then above the x squared is the square root. It gives you the square root symbol. And then I'll type in 117 and then enter. In this case, that gives me y equals 10.8166. I look to the third digit. In this case, that number is 5 or more. It's 6. So that means my answer is approximately 10.8, and that 1 rounds up to a 2. Now for the third problem, again, I'm going to find the C first. I'm going to find the right angle, go across from it. That will be my C. The A and the B are the two other sides. Notice it doesn't really matter which A and B I label after I've labeled the C. The C is the most important side because it is the hypotenuse and the longest side. So in this case, I'm going to get 10 squared equals 3 squared plus x squared. 10 squared is 100 equals 9 squared plus x squared. Notice how that equals separates, not 9 squared, excuse me. Why did I write a squared? I already squared 3 and got 9. That should just be a plain 9. So that should be 100 equals 9 plus x squared. Notice that the 100 and the 9 are on separate sides of the equals. So that means I will take 100, subtract 9, and get, well, not 10 subtract 9, 100 subtract 9, and get 91 equals x squared. When the unknown is a leg, you will subtract. When the unknown is the hypotenuse, the numbers are on the same side and you will add. And then this gives you x equals the square root of 91, second square root of 91. And I'm going to kind of just use the calculator this time. And that 5, 3, the third digit is a 9. So that 9 is 5 or more. And so since that 9 is greater than 5, that 3 rounds up. So we have approximately 9.54. And that finishes problem number 9. So now let's flip over to the next page, the third page, which is problem number 10. In problem number 10, we're asked to evaluate the expression using the given information. In this case, we have 3 plus x squared plus y, and we're given the values for x equals -3 and y equals 2. So that means we're going to go 3 plus, and I'm going to put parentheses and a squared, and in place of that x, I'm going to put a -3 plus parentheses for my y, and in place of that y, I will put a 2. And then I have an order of operations problem, and I just complete it. Negative 3 squared, I do my exponent first. Negative 3 times negative 3 would be a positive 9. 3 plus 9 plus 2. And 3 plus 9, 9, 10, 11, 12. Plus 2 would be 14. And we always want to check these using our calculator, unless it's on the no calculator part. So 3 plus parentheses negative 3 squared plus parentheses 2. Notice when I do this, I use parentheses to show where I plugged in the number, because one of the mistakes that I tend to make is to plug in the wrong number, and I can say, well, the second parentheses is my y, did I plug in a 2? The first parentheses is my x, did I plug in a negative 3? And did I type that into the calculator the way that it looks? And yes, I did. So that way I can double check my work. Okay. The next problem says 4 minus x. So I'm going to leave a parentheses for my x. Come over here and find out what my x is, and it's a negative 5. Subtract my y, and come over here and find out what my y is, which is a positive 2. Then I can come back over here and say, well, that negative and negative, 2 negatives there mean I need to change that to adding the opposite, so that makes it a plus a plus. So what I really have is 4 plus 5 subtract 2. 9 subtract 2 is 7. So if I put that in the calculator, that would be 4, subtract a negative 5, subtract 2. Again, notice how I leave the parentheses there to show that that's 4. Subtract the x value, which is negative 5. Subtract the y value, which is positive 2. And that then should give me 7, which it does. For the next problem, I have to roll back here and get my glasses again. Okay, there we go. It's apparently I can read squares, but every time I get to a cube, I have to put my glasses on. So that would be x cubed. And what is my x? Well, it's a negative 2 plus 2x squared. And what is that? X is a negative 2 plus 4 times the x, which is a negative 2. Well, negative 2 to the third power, you could use the calculator if you need to on that. But you could also say negative 2 times a negative 2 is a positive 4. A positive 4, and notice you couldn't see, but so I put my fingers up here, but I said negative 2 times negative 2 is a positive 4 times a negative 2 is a negative 8. So I counted the number of times I was multiplying. So that gave me negative 8 plus a negative 2 times a negative 2 is a positive 4 plus 4 times negative 2. I took care of my exponents. Negative 8 plus 8 plus a negative 8. And so the negative 8 plus 8 is 0, plus a negative 8 should be negative 8. And again, we can type it in the calculator. Negative 2 raised to the third plus 2 times negative 2 plus 4 times negative 2. Whoops, now what did I do? I did it, and I've been trying so hard during this thing. I did all of those in the exponent. It should be 2 raised to the third, and always hit that over key. I always forget to hit that over key. So let's do that again. I hit the third, and then I hit the over key so that the next parts that I hit are down. So 2 times negative 2 raised to the second, and then hit the over key so you're back down on the bottom and not all in the exponent, plus 4 times negative 2, and then you get the negative 8, which is the correct answer. Okay, in the next problem, we'll have a division. Notice there's a top and a bottom. A fraction bar means division. So I will want to figure out the top figure out the bottom and then divide. So for the top, I have 6 times the x, which is 3, plus 15 times the y, which is -4, all over the x, which is 3 minus 2. Now on this bottom, I really don't need that parentheses, but I use the parentheses to really emphasize that the 3's are the x's and the -4 is the y. 6 times 3 is 18. 15 times -4 is -60. So that just becomes -60. 3 minus 2 is 1. 18 minus 60 is -42. And any number divided by 1 is itself. Now, if we put this in the calculator, I really wouldn't recommend putting it in the calculator in one step, but recommend doing 6 times 3 plus 15 times -4 and getting the top. 3 subtract 2, getting the bottom, -42 divided by 1, and getting the final answer. Okay, notice the next problem has the bars. Remember, your bars are your absolute value. That means whatever we get inside of there will be made positive when we do that last step. And I will do that as the last step. They also act as grouping or parentheses. So the parentheses, which we use, and please excuse my dear Aunt Sally, the absolute value really act as a parentheses. If you use the GEMA, that's a grouping symbol, and a grouping would be like in the fraction here or in the absolute value. So what we would do here is that would be the absolute value of your x, which is 5, plus your y, which is -2, plus 3 times your z, which is 8. So we would do the inside first. And so I would do that multiplication, 5 plus -2 plus 24. And in this case, I think it's going to turn out to be positive anyway. 5 plus a -2 would be 3 plus 24, which would be 27. And the absolute value of 27 is just 27. So if we did that on the calculator, what would we get? We would get, and you can do an absolute value on your calculator. If you go to math and go over to number, you see where it says ABS? That would be your absolute value. Some of your older calculators will say ABS in a parentheses. My newer calculator actually uses the bars. So if yours says ABS in a parentheses, you'll type it in and then end it there at the end. For me, I'll go 5 plus a -2 plus 3 times 8. And I didn't put those in parentheses because they were fairly simple. And there's the 27. I'm going to stop this one right here. Because of the time issues, I'd like to keep these short. So this is problems 9 and 10. I hope this was helpful. If you need any help, you can contact me at beth.dixon@ws.edu. Thank you for watching.